this section, we'd like to talk about another method for solving a quadratic equation, and that's called the quadratic formula. Now, the quadratic formula is derived from a method for solving quadratic equations called completing the square, but that's not a topic that we cover in this class, so unfortunately, I'm just kind of throwing this formula out there to you and go, here you go, this is it, you just need to know it. If any of you are curious about the proof of the quadratic formula, there's a development for it. You have to learn how to complete the square first, and then you do that for ax squared plus bx plus c equals 0. But if you're very curious, I would be glad to show you. I'd make a video for it, or you could probably Google it and find a good explanation online. But anyway, here's the formula. Now, a couple of things I want to point out here. First of all, you have to have a quadratic equation. So basically, this x squared that we got going on right here, that is required, okay? If it doesn't have an x squared in it, if it's an x to the third or an x to the first, you're not dealing with a quadratic equation, therefore you're not going to use the quadratic formula. Now, there are extenuating circumstances of polynomials that are called quadratic types, but so I don't want to tell you 100% of the time it's got to be square. There are unusual circumstances, but everything we do is going to have a square in it. Now, another thing that has to happen is you have to have that 0 on the other side. So there is no using the quadratic formula until you have it in this form. So notice it's ax squared. So a is the number being multiplied by the x squared. B is the number multiplied by the x, and C is the constant. And again, you need 0 on the other side. So notice the formula. It's a big fraction. You have whatever variable is in your problem. If it's an x in your equation, then you would use x equals. If it was a z in your equation, you would put z equals. And the formula is negative b, and then plus or minus. Okay, that's probably because we took a square root. And there's your square root, okay, of b squared. So this guy right here squared minus 4a is the number times the x squared. C, the constant, all divided by. So that fraction bar goes all the way across 2a. So what I propose here is to use the quadratic formula on a problem we actually already know how to solve. Now, what do I mean by we already know how to solve it? Well, this problem factors. And just to show you we get the same answer, let's do it the way we already know how to do it. So I'm looking for numbers that multiply to be 6 and add to be negative 5. And you probably got those as minus 3 times the minus 2, and that equals 0. Then the next step is you set each of these factors equal to 0, and then you add the 3. And so there's one of your solutions, and you add the 2, and there's the other solution. Okay, we already know how to do this, but the problem is every single quadratic equation doesn't have a trinomial that factors, okay, or the quadratic that factors. And I want to show you again on this problem. So let's try this in green. For our particular problem, our a, remember, is the value times x squared. What are we multiplying by x squared? Well, there's a 1 there. Our b is the value times x. You have to take the sign with it. It is negative 5. And our c is the constant value, which is a positive 6. And then you plug this directly in the formula. So there's an x in our problem, so I'm going to write x equals, and you have negative b, so negative of a negative 5, and then plus or minus the square root of b squared. So that's going to be negative 5 squared. Minus 4. Notice the parentheses around the negative 5 because you're not just squaring the 5, you're squaring the negative and the 5. So I had to use parentheses. For a is 1, and then c is 6. That's all underneath that square root. And then this fraction is underneath the entire expression. So that's all over 2, and then a again is 1. Now your next step, and all of your next steps are going to be simplifying. So this negative of a negative 5, that turns that 5 to positive, plus or minus the square root. Now negative 5 squared, that's negative 5 times negative 5, which is 25, minus 4 times 1 times 6, that's 24, and that's all over 2. Now I'm going to go to the right over here and keep going. So this bottom line is equal to x is equal to 5 plus or minus. Now this 25 minus 4 we know is 1 over 2. Now remember in the last section that we talked about using the square root property, this is really two different answers. So at some point we're going to split this up. We don't have to yet. Plus or minus the square root of 1 we know is 1 over 2. But now it's time. We must split this up. So I have two answers. One of them is 5 minus 1 over 2. The other one is 5 plus 1 over 2. Do not leave it there, because 5 minus 1 is 4 over 2, which we know is 2. That's one of our results. Right here, we have 5 plus 1 is 6 over 2, which of course is 3. Now look, we got the same answer. Obviously for this problem, factoring is easier than using the quadratic formula. But the thing is, again, many quadratic equations do not have quadratics that factor. So this is the alternative to get you out of that. So let's try this again, and that's what we're going to do the whole video. We're just going to run into different issues that you find when you use the quadratic formula. Now the first thing I want to point out every time is two things you need to know. It must equal 0. If your quadratic equation does not equal 0, you have to do the steps to get it to equal 0. The next thing, make sure you pick out your A, B, and C correctly. So you may want to write it in descending order. So in this case, A is 3. Note here, it's not 3x squared. It's just 3. B is negative 5, actually like it was in the last problem. And C is 2. I think it's worth writing down right in front of you just so you're confident about it. So we have x is equal to negative of a negative 5, again just like the last problem, plus or minus the square root of negative 5 squared. Again, these parentheses right here, they're required, okay, because of the negative. Minus 4 times a is 3, c is 2, and this is all divided by 2 times 3. Now continue to simplify this. I'm going to move to the left here for space reasons. Negative of a negative 5 is 5. Plus or minus the square root, negative 5 squared is 25. Minus 4 times 3 is 12, times 2 is 24. And that's all divided by 6. So the next step is always going to be to do your subtraction. So your big goal here really once you get started is to simplify under the square root. So you're going to square, you're going to multiply, then you're going to subtract every single time. So I squared to get the 25, I multiplied to get the 24, and now I'm going to subtract. So that gives me, I changed my color, 5 plus or minus the square root of 1 over 6. Which gives me 5 plus or minus the square root of 1 is 1 over 6. And we split that up into two different answers now, because I can't do any more simplifying here. I have 5 minus 1 over 6 and 5 plus 1 over 6. Simplify, 5 minus 1 we know is 4 over 6. If I keep simplifying that, 4 6 2/3. You do need to reduce any fraction to lowest terms. The second answer, 5 plus 1 is 6 over 6, and we know 6 divided by 6 is 1. So I have two answers. Now, here's a hint. Anytime you're using the quadratic formula and the value under the square root, so right here is what I'm talking about, there's a 1. Anytime that value is a perfect square, that actually means that polynomial would have factored. Didn't mean it had to, but just it was an option. It would factor anytime b squared minus 4ac is a perfect square. But there are many problems you will see that that's not going to be a perfect square, which means this is the only way to solve it, unless you know how to complete the square, which we don't cover in this class. So there you go. All right, so a third problem. First of all, let me ask you, do we have the conditions we need? First of all, do we have a quadratic? Well, you say yes we do, and the reason you know we do is because we have a square. The next thing is it equal to 0? Yes, it is, which as long as you have those two things, then you are allowed to use the quadratic formula. So our A is the number times your variable squared, so it's 4. Our B is the number times your variable to the first power, so 2, and our c this time is a -6, so you make sure you take the signs with it. All right, now our variable is z, so instead of saying x equals, this time I'm going to say z equals, and it's going to be negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Notice I wrote the formula down this time because I don't have it in a big green box at the top. So here we go. Negative 2 plus or minus the square root of 2 squared. Now notice I didn't put parentheses around the 2 that time. It's nothing wrong if you do, but I didn't have a negative b this time, so they weren't required. So minus 4 times a is 4. My c is down there is a -6. All over 2 times 4. Now continue to simplify. That is still z equals -2 plus or minus the square root. Now 2 squared is 4. And here's where I want you to be really careful on this problem. This is like a -4 times a +4 times a -6. So this negative times this negative is positive, right? I see a lot of people miss the signs when dealing with the quadratic formula. Then I'm going to multiply 4 times 4 times 6 to get 96. And that's all over 2 times 4, which is 8. Remember, so you square b, you multiply here, and then you do whatever operations. Earlier I said, and then you subtract, but this actually turned into addition, right? So I'm going to go to the top right of the page and continue. So this is z equals, and I'm going to have -2 plus or minus the square root of, that's 100, all divided by 8. Now we know 100 is a perfect square, so I'm going to take the square root of 100 and get 10 over 8. Now here's what I know is that had I attempted to factor this problem originally, it would have factored. Now don't stop and go back and factor it, unless for some reason you need to, but you can keep going because we're almost finished. So z equals. Now you've got to split this up into 2 separate problems. You could simplify at this point, but it's too confusing. Just split it up. So it's -2 minus 10 divided by 8, that's one of your answers, and -2 plus 10 divided by 8. I continue to simplify. -2 minus 10 we know is -12 over 8. If I simplify that fraction to lowest terms, 4 goes into both of those, so 4 into 12 is 3. Negative still there. 4 into 8 is 2, so -3 halves. My second answer, I get 8 over 8 when I add the -2 and 10, and then I reduce that to get 1. So I do have 2 solutions, because quadratic equations have 2 solutions. It can just have 1 solution, but in theory it's the same solution twice. And it can have no solutions, and you're going to see what causes that as well as we continue. Alright, so this video is completely full of these examples. I want you to pause and try this one. Now, I will tell you, this one looks like it factors to me. Are you back? Did you figure it out? But it does say solve the quadratic equation using the quadratic formula, so that's what I want to do. And remember the things you're checking for. You must have it equal to 0, check, and it must be a quadratic, check. So we know our a value, which has nothing to do with this a, by the way. Just the a being the number in front of the a squared is 1. B being the number in front of the a to the first power, which is -2. And the c value being the constant, which is -15. So I have a equals, because that's what's the variable in my problem, -b plus or minus the square root of b squared minus 4ac all over 2a. So if you don't have what I have here, stop. Pause, figure out what the problem is. Now let's keep going. Negative of a -2 is 2 plus or minus the square root of -2 squared. Not just -2 times 2, but -2 times -2, which is 4. This number will always be positive. 4 times 1 times 15, negative. This negative times this negative makes a positive, and 4 times 15 is 60. And that's all divided by 2 times 1, which is 2. Now keep going. Now I do the addition or subtraction. This is addition to plus or minus. The square root of 4 plus 60 is 64. Notice once again we have a perfect square, which means this problem would have factored. So I continue to simplify. I have a equals 2 plus or minus the square root of 4 is 8 over 2. So once I take the square root, then I don't write the square root symbol anymore, and then I can subtract 2 minus 8 over 2. That's one of my answers. And 2 plus 8 over 2. 2 minus 8 is negative 6 over 2. 2 plus 8 is 10 over 2. Negative 6 over 2 is negative 3. 10 over 2 is 5. And there's my two answers. It's getting easier now, right? All right, let's check out those things we need. Do we have a quadratic? We do. Is it equal to 0? It is. So we find A is 2, B is positive 8, and C is positive 5. So I have P equals negative 8, because of a negative B, plus or minus the square root. Next is B squared. So that's 8 squared minus 4 times A, which is 2, C, which is 5, all underneath the square root right there, all divided by the entire fraction, 2 times 2. So then we have negative 8 plus or minus the square root of 64. Now you have 4 times 4 times 2 is 8, and 8 times 5 is 40. So that is minus 40, all divided by 4. Almost wrote 2, about 4. There we go. Now continue to simplify, which means I need to subtract underneath that square root. That gives me 24 over 4. If you'll notice, this is the first problem we've had where the value under the square root wasn't a perfect square. So now I need to simplify that square root as much as possible. The square root of 24 I can write as the square root of 4 times 6, and that's all over 4. I continue simplifying. That's negative 8 plus or minus. Now the square root of 4 we know is 2, square root of 6. And we spent an entire section on simplifying square roots. Now, these I cannot add together. Okay, so I can't just say negative 8 plus 2 like we did in the last ones. It is time to split this up. Let's do that. So it's negative 8 minus 2 square root of 6 over 4. And the other one is P equals negative 8 plus 2 square root of 6 over 4. But I want to show you something. I'm going to highlight this for you so you can see it. This value, and this value all have common factors. So if you can't just simplify the 2 and the 4 and ignore the 8. You also can't simplify the 8 and the 4 and ignore the 2. So in theory, what you're doing is you're factoring out the common factor that all three of these share. But to save you a second, you can divide each of those by their common factor. 2 is it. So 2 goes into 8, negative 4. 2 goes into 2, 1. The square root of 6 is still there. And 2 goes into 4 twice. Now that minus 1 in the front is not required. So it would be negative 4 minus the square root of 6 over 2. The same thing here. And a matter of fact, we could have done this before we split it up, and we will in the future. But all of those simplify into negative 4 plus the square root of 6 over 2 for the same reason. Okay. Now another option, and I'm going to erase over here to the left so you can see this, is to split these up into two separate fractions. So you can write this as negative 8 over 4 minus 2 square root of 6 over 4. I often teach that, so I'm going from here to here. And then the negative 8 over 4 reduces to negative 2. And then the 2 and the 4 cancel to leave a 2 in the denominator. This is the same result as that. I know it looks different, but it is exactly the same value. And both answers are correct, so you could give either one. Alright, so example F. Again, do we have what we need? We do have a quadratic equation, and it is equal to 0. So take a minute, select A, B, and C, plug it in the formula, see if you can get it simplified, and then compare it to my work. So I hope you're done now. A is 5, B is negative 11, and C is equal to 3. So again, A is the value in front of your q squared, B is the value multiplied times your q, and C, which is positive 3, is your constant. So in my formula, I have q equals negative B, so negative of a negative 11, plus or minus the square root of negative 11 squared, minus 4 times A, which is 5, times C, which is 3. And this is all divided by 2 times 5. My next plan is to simplify. The negative of a negative 11 is 11, but under the square root. Negative 11 times negative 11 is a positive 121, and then 4 times 5 is 20, times 3 is 60. So we're going to subtract 60 from 121, and I also did 2 times 5 is 10. So continuing on, q is equal to 11 plus or minus the square root of 121 minus 60 gives me 61 over 10. And here's the thing. Square root of 61, as far as I know, will not simplify. So you write this as two separate answers. One of them is q is equal to 11 minus the square root of 61 over 10. And q is equal to 11 plus the square root of 61 over 10. Unlike the last example where this value, let me show you again, this value, the value in front of the 61, and this value don't have any common factors but 1. Therefore, this is not going to simplify at all. We're just finished with this quadratic equation. Another example, just to make sure we're comfortable with this. So you have A is equal to 3, B is equal to 12, and C is equal to 7. Let's see where that takes us. So I have M is equal, because M is the equation in my problem. Notice it is equal to 0, so I'm allowed to jump in and do this. M is equal to negative B, so negative 12, plus or minus the square root of B squared, so 12 squared, minus 4 times A is 3, times C is 7. And this is all divided by 2a, so 2 times 3. That gives me negative 12 plus or minus the square root of 144 minus, now 4 times 3 is 12, times 7 is 84, and that's all divided by 6. So it's equal to negative 12 plus or minus the square root of 60 over 6. Now, does 60 have a perfect square that divides evenly into it? And it certainly does. 4 is it. It's not a big one, but it'll simplify. So negative 12 plus or minus, and I don't want to lose my m. This is really m equals, right? Plus or minus, that's the square root of 4 times the square root of 15 over 6. Where did the 4 and 15 come from? 4 is the largest perfect square that divides into 60. 4 times 15 is 60. Now what I'm going to do next is I'm going to simplify the square root of 4 part, which is 2, and leave the square root of 15. And that's all over 6. Now remember what we talked about before? Let me highlight this for you. This value, and this value. Do they have any common factors? And they do. A 2, right? 2 divides into all of those. So that's going to give me negative 12 divided by 2 is negative 6. 2 divided by 2 is 1, and then the square root of 15 is still there. 6 divided by 2 is 3. Now you could write that in two separate answers. Negative 6 minus the 1 in front of the square root of 15 is not required over 3, and the other one is negative 6 plus the square root of 15 over 3. Now you're looking at that 3 and the 15, or the 3 and the 6. The 3 and the 6 you could simplify if you split these up into two fractions like this. Negative 6 over 3 minus the square root of 15 over 3. And then you could say that's negative 2 minus the square root of 15 over 3. That's an appropriate answer as well. But this is perfectly fine. Okay? So I suggest trying this one. A equals 5. B equals 4. C is equal to negative 4. So you have n equals negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 5, c, which is negative 4, and that's all divided by 2 times 5. I continue to simplify. That's negative 4 plus or minus the square root of 16. Now watch this, careful. Negative 4 times positive 5 times negative 4. That's going to be a plus. And then you do 4 times 5 is 20 times 4 is 80. All divided by 10. That's still n equals. I keep going. N equals negative 4 plus or minus the square root of, now 16 plus 80 is 96 over 10. Now what I'm thinking is I need the biggest perfect square that divides evenly into 96. And what is that? And that is 16. So I'm going to rewrite 96 as the square root of 16 times the square root of 6 all over 10. That's negative 4 plus or minus 4 square root of 6 all over 10. Now, here we are again. I need to simplify. Is there a common factor for those three values? And you're going to go, yes, Miss Wilson, of course there is. There's a 2 that divides into all those. So that's what I'm going to do. So n is equal to negative 4 divided by 2 is negative 2. Plus or minus 4 divided by 2 is positive 2. Keep the square root of 6, and don't forget 10 divided by 2 is 5. And there are my two answers. Okay, so negative 2 minus 2 square root of 6 over 5. And negative 2 plus 2 square root of 6 over 5. You cannot add this negative 2 and negative 2 together or subtract because these are paired together and there is no separating that, okay? These are not like radicals. So this is your final two answers.